Good morning, students. Welcome into the another session of CS02 problem solving methodologies using programming in C. In last lecture, we have gone through the various control structure in C like entry level control statement called while and exit level control statement do while. Generally in our all the topics we follows our protocol that first we discuss about the description of the topic, then we go for the description of the topic, then we'll have a discussion about the syntactical part of entire topic, then we go for the example which is related to the topic. So now we are starting with another type of looping control structure in C, that is for loop. This is very important in entire subject, so please listen every words very carefully. For is another type of looping control structures which is available in C, and it is common in almost all the programming languages. Now as you can see onto the screen, I have mentioned the syntactical part of for loop, where for is the keyword for initializing the loop, then into the bracket first initialization we have to give, then there should be a one semicolon, then there is a conditional part, then another semicolon is there, and then we have to give increment and decrement as a third part, and at last we don't have to write semicolon. So just remember the syntax of for loop. Again I am repeating the word. Into the syntactical part of for, it consists of three sections. Section number 1 is initialization, which is followed by semicolon. Next part is condition, which is also followed by the semicolon, and the third part is increment or decrement, which is not followed by the semicolon. So in this way we can write the syntax of for loop. In a very next line, there is a simple example of for loop I have written. You can see that for into the bracket I equals to 0, that is called as initialization. Then there is a semicolon as per the syntax. Then I less than 5 is a condition followed by the semicolon, and into the third part I plus plus is there, which is a incremental part of the program. So I plus plus is written and then after there is no semicolon mentioned into the entire block. So in this way we can write a for loop. Now theory of for loop says that for loop is most widely used looping control statement in programming because it has initialization, condition, increment and decrement into the single line. Now if you observe into the while and do while statement which we have completed into the previous lecture, it contains all these sections, that is initialization section, condition section, as well as increment and decrement section is in a separate line. So this is the benefit of using for loop. That means in a single line we can mention initialization, condition or increment and decrement in a single line. Now this loop is widely used because it reduces the number of lines from the entire code. This is but obvious in while and do while. For initialization it occupies the single line, for example. For condition checking it occupies another line. For increment and decrement it also occupies the third line, and the remaining some lines are for the logical block of code. So it increases the total number of coding lines into the while and do while, which makes our code complicated. But in for loop this facility is given by the for loop, that in a single line we can write initialization, condition and increment and decrement. So the total number of programming line gets reduced and the complexity of the entire program can also be reduced. Now in this loop more than one variable can be initialized and can be separated by comma. This is another functionality, or you can say the characteristic of for loop have. In for loop, in a single line, we can declare and initialize multiple variables which can be separated by comma. I will show you this thing practically into the program also. Now, as I have mentioned into the syntactical part of for loop, it consists of three sections. The section number 1 is initialization, section number 2 is condition checking, and the section number 3 is increment or decrement. Even these sections are also called as phase. So phase 1 is initialization, second phase is condition checking, and the third phase is increment or decrement. Now suppose we want to include for loop into the flow chart. Then in this way we can go ahead by adding for loop into the flow chart also. First there is an initialization, then there should be a condition checking. If this condition is true, then the body of statements executes. It increments or decrements the value, and program gets repeated till the condition is true. That means this portion repeats till the condition is true. But once the condition is false, that program terminates by itself and goes out of the body of the statement. So in this way we can include the for loop control structure into the flowchart. Now we need to write a one simple program which demonstrates the use of for loop. So for that I am going into the Turbo C compiler. Then here I am giving the definition called write a program to print 1 to 5 number using for loop. See students, I am taking first 3 to 4 program common for while loop as well as in do while loop as well as in for loop, because you can simply compare that what's the difference between the same program in sub theoretical sections like while loop, do while loop and for loop. You just compare the program of 1 to 5 number with do while loop and for, and vice versa. Now let's start the code. After writing the structure of C, let me remove the last programming line that I have done. Here I am initializing one variable called integer I, then CLR SCR, then simple. Here I have to mention a for loop. So for that the keyword is for I equals to 1, because I want to start my entire series from 1. I less than equals to 5. It's a conditional part. As you can see that after I is equals to 1 I have written semicolon, then again after the condition even I have mentioned the semicolon, then the last one is I plus plus, then there is no semicolon, into the brackets printf %d comma I. Save this particular program, check for the syntactical errors. As we can see that there are no syntactical errors. Just execute the code. You can see that there is a 1 2 3 4 5 onto the screen. Let's put a new line character into the printf statement which prints every number into the separate line like 1 2 3 4 5. So now what's your task is just compare the total number of lines which for occupies into the editor of C. I can see that there are 12 lines, right? Over here it is mentioned 12. Now just go into the program of 1 to 5 number using do while loop, or you can say the while loop, and counts the number of lines which occupied by that particular program 110%. That counting is greater than this particular count. So for is an interactive loop which occupies a very less number of space inside the editor, and even it give more powerful output onto the screen. So just focus more onto the for loop. Now let's see this particular program into the notepad for better visibility purpose. So I am opening C drive, turbo C, disk, turbo C bin, and the file that I have saved is 2.c. I am just opening it. That's it. There is a first line of code is hash include stdio.h, where hash is a preprocessor directive, include is to call the library. This opening and closing brackets are the syntactical part of the C structure. stdio.h means standard input output.h, where std means standard, I means input, o means output, dot itself is a symbol, and h means header. So this is the justification of stdio.h. Then there is a main executable statement called void main. Then there is an opening bracket and closing bracket. First line of code is integer I. This is my local variable declaration where I have declared the variable called I. Then there is a CLR SCR, which is my basic function for clearing the buffering screen. Then there is a keyword for into the bracket. This is the first part of the syntax, that is initialization. I have initialized this I with 1 because my series I want to start with 1 itself. Then there is a semicolon. It's a part of syntax that we have discussed into the theory. Then I less than equals to 5, it is a condition. Then again it is followed by the semicolon. Every time I want to increment the value of I, that is 1 by 1. That means I need an increment operator. So here I have mentioned the postfix increment operator. Even you can go for prefix increment operator, but generally postfix increment operator is widely used. Then into the brackets, I am simply printing the value of I in every new line. This loop repeats, starts with 1, then it checks that 1 is less than equals to 5. Yes, 1 is less than equals to 5. It increments the value of 1 by 1, that is I equals to I plus 1 makes 2. It prints first I, then in a second repetition it prints 2, then it prints 3, then it prints 4, then it prints 5. 5 became 6, but for 6 this condition becomes false. So entire repetition of the program terminates, and on the screen we'll get an output 1, 2, 3, 4, 5 in separate line. So in this way for loop will display 1, 2, 3, 4, 5 number onto the screen. Now let's practice some more programs. My next program is write a program to print 1 to n number using for loop. It's very simple. In this program will accept our number from the user, and up to that number for loop repeats the statement and prints the number. I will extend this particular program for 1 to n. So for that, after CLR SCR I am giving a one label, enter your number. Then for reading that number, scanf %d %n. So I need to declare this n variable in a declaration section. Then there is a for loop for I equals to 1 remains as it is, I less than equals to n, I plus plus remain as it is, printf %d /n remains as it is, and that's it. Let's check that particular program, will it work or not. See, as you can see that program waits for the user to get entered some value. Say for example, suppose user enters the value called 8. Loop repeats 1 to 8 time, and it prints 1, 2, 3, 4, 5, 6, 7, 8 onto the screen. Let's rerun the code. Now I am giving a very less value, say for example 5. So loop repeats for the 5 time and it prints 1 2 3 4 5 onto the screen. So in this way, this particular program will print 1 to n number using for loop. I hope all of you understands how to write a sample code using for loop. Let's see this particular program in Notepad for better visibility purpose. There is a two variable declaration I and n. Then there is a printf, enter your number, it's a label. Scanf %d n %n. Say for example here I have entered 5. So what is the purpose of entering this value? It repeats this particular loop up to that number. That means it starts with 1, and here I have mentioned I less than equals to n, where n is 5. So this particular loop repeats 1 to 5 times, and it prints 1, then 2, then 3, then 4, and then 5, and it also becomes 6, but for 6 this condition becomes false. So this repetition terminates, and onto the screen there is an output called 1 2 3 4 5. So in this way for loop works. Let's practice more. Next program is, this is very important for university examination. Write a program to print Fibonacci series. Yes, a very complicated word to speak, that is Fibonacci series. So first let's clear that what is Fibonacci series, how it is printed, and what is the logic behind printing the Fibonacci series. So for that, let me go inside the programming section. I'm just demonstrating Fibonacci series in C. This is the Fibonacci series. Let me take it into the notepad. Zero, 1, 1, 2, 3, 5, 8, 13, 21, and 34. Now let's see what's the logic behind this, how this series get printed and why it is called as Fibonacci series. So for that we need to take two fixed numbers, that is number first number is 0 and the second number is 1. Again I am repeating my words. This is the Fibonacci series. To print this Fibonacci series, I need to take two separate numbers, where number 1 is 0 and number 2 is 1. That means my first number is 0 and second number is 1. Clear? Now what I have to do, I have to repeat the number of statements. I have to repeat the program using loop, where it add first number with the second number. If I add 0 plus 1, it becomes 1 as an addition, right? Now in next repetition, this becomes my old number and this becomes my new number. That means number get interchanged. This becomes old number and this becomes new number. I have to add these two number, which gives 2. Now this number becomes old one, and whatever the output becomes new number, I have to add these two numbers, which gives me 3. This becomes old number and this one becomes newer number, which gives me an addition called 5. Then 3 becomes old and 5 is the new number. 5 plus 3 is 8. 5 becomes old, newer one is 8. 8 plus 5 is 13. Then 8 is the old one, and 13 is newer. So 13 plus 8 makes 21. Then 13 plus 21 makes 34. So you can see that the same series gets by performing this particular logical statements, right? Now in this entire series, these are the two fixed number. Just count this number: 1, 2, 3, 4, 5, 6, 7 and 8. There are 8 repetition will give this Fibonacci series onto the screen. So I hope all of you have a clear-cut idea about how the Fibonacci series gets generated. What's the logic behind this? We need to implement it. So let's try to implement this Fibonacci series logic using programming in C. This program is very important for university. Write a program to print Fibonacci series, SERIES series, using for loop, right? Now first number I want to take I is equals to 0, it's a fixed number. Then j is equals to 1. Then into the for loop, before this for loop, I am printing the value of I and j as it is onto the screen before the repetition. Just remember that I am printing the value of I and j as it is onto the screen. Let me check the logical sequence again. One and 2. Fine. Take this one as a n1, take this one as a n2, print n1, that is number 1, number 2 as it is onto the screen. Starts the repetitive control statement from 3 to, say for example, 10. Let me do it for 10 yet, then we'll remodify the program if something goes wrong. Then printf %d, I don't want slash n yet, n1 plus n2. Then n1 becomes n2 and n2 becomes n1. This is the logic for interchanging the numbers. Let's cross check this thing. Will it work or not? Fine, it's proper, but one thing is missing. Here I have to take a third variable that is called as n3 which stores the addition of these two numbers. So I am removing this n1 plus n2 from the printf statement, and I am storing it into the n3 variable, and that is n3 equals to n1 plus n2, and I am printing n3 into the printf statements. Let me check first, is it work or not? 0 1 0 1 1 2 2 2, then okay, something is wrong. Let's check it by debugging the code. Here the value of n1 is 0, fine, n2 is 1, fine. So 0 is printed, then 1 is printed. Okay, it's perfect. Then this loop repeats from third. Now this becomes 0 plus 1, n3 is 1. Now n1 is n2. Value of n2 is 11. That means it becomes 1. n2 becomes n1. Here the mistake is there. Here I have to write n2 is equals to n3, because n3 is my newer number. Now let's put a one space over here, which gives a proper numbering onto the screen. 0 1 1 2 3 5 8 13 21 34. That's it. It works properly. Let me give one more space even over here too. 0 plus 1 1, 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13, 13 plus 8 21, and 21 plus 13 34. That's it. This is the perfect Fibonacci series getting printed onto the screen. Now let's understand this particular program by debugging the code. You can see that there is a value of n1 is 0. Just fix this n1 equals to 0 in your mind first. Clear? Now second is n2 is equals to 1. Let me speak in Gujarati. n1 ની વેલ્યુ 0 છે, એ મગજમાં ફિક્સ કરી દો. થઈ ગઈ. n2 ની વેલ્યુ 1 છે, એ ફિક્સ કરી દો. થઈ ગઈ. n3 એક લોકલ વેરિયેબલ છે અને i પણ એક લોકલ વેરિયેબલ છે. હવે સૌથી પહેલાં n1 ની વેલ્યુ એમનેમ સ્ક્રીન ઉપર પ્રિન્ટ થઈ જશે. એટલે કઈ પ્રિન્ટ થશે? યસ, 0. પછી અહીંયા n2 ની વેલ્યુ પ્રિન્ટ થશે. કઈ પ્રિન્ટ થશે? યસ, 1. હવે આ જે લૂપ છે એનું રિપીટેશન થર્ડ સ્ટેજથી ચાલુ થશે, કેમ કે 0 અને 1 પહેલાં બે નંબર તો આવી ગયા, ત્રીજો નંબર જે છે ત્યાંથી આપણે સ્ટાર્ટ કરવાનું છે. એટલે અહીંયા મેં i ઇક્વલ્સ ટુ 3, i લેસ દેન ઇક્વલ્સ ટુ 10, i પ્લસ પ્લસ લખ્યું છે. એટલે આ લૂપ કેટલી વાર રિપીટ થશે? થર્ડ એટલે પહેલી ટાઈમ ગણવાનું. થર્ડ, ફોર્થ, ફિફ્થ, 6, 7, 8, 9 અને 10. એટલે કે 6, 7, 8 ટાઈમ્સ આ લૂપ જે છે એ તમારી રિપીટ થશે. હવે આ પહેલી વખત રિપીટ થાય છે. 3 ભલે લખો પણ લૂપ પહેલી વખત રિપીટ થાય છે. ત્યારે શું લખેલું છે? n3 ઇક્વલ્સ ટુ n1 પ્લસ n2. હવે n1 ની વેલ્યુ કેટલી હતી? 0. n2 ની વેલ્યુ કેટલી હતી? 1. એટલે 0 પ્લસ 1 n3 માં કેટલા આવશે? 0 પ્લસ 1 1 આવશે. એટલે અહીંયા 1 પ્રિન્ટ થશે. હવે શું થશે? n1 માં n2 ની વેલ્યુ જતી રહેશે. એટલે n1 થઈ જશે 1 અને n2 માં n3 ની વેલ્યુ આવશે. એટલે કેટલી વેલ્યુ આવશે? 1. રિપીટ થઈને ઉપર જશે એટલે 1 પ્લસ 1 થશે. એટલે n3 ની વેલ્યુ 0 1 પછી કેટલી પ્રિન્ટ થઈ હશે? 1 પ્રિન્ટ થઈ હશે. હવે n1 ની વેલ્યુ કેટલી થશે? જે લાસ્ટ પ્રિન્ટ હોય એ કેટલી છે? તો કે 2. નવી વેલ્યુ કેટલી આવશે n પ્લસ 1 ની? એટલે કે 2 પ્લસ 1 કેટલા થશે? 3. રાઈટ. હવે 3 છે એ ન્યૂ વેલ્યુ છે અને 2 છે એ ઓલ્ડ વેલ્યુ છે. એટલે 3 પ્લસ 2 કેટલા થશે? 5. પછી 5 પ્લસ 3 કેટલા થશે? તો કે 8. 8 પ્લસ 5 કેટલા થશે? તો કે 13. 13 પ્લસ 8 કેટલા થશે? 21. 21 પ્લસ 31 કેટલા થશે? 34. 34 મારો લાસ્ટ ડિજિટ છે ત્યાં લૂપ જે મારી ફોર લૂપ છે એ રિપીટેશન કમ્પ્લીટ કરી દેશે, એટલે સ્ક્રીન ઉપર આપણને ફિબોનાકી સિરીઝ આ રીતે દેખાડશે 0 1 1 2 3 5 8 13 21 અને 34. એમાં 0 1 ફિક્સ છે, એ કાઢી નાખો. એટલે આપણે ગણીએ 1 2 3 5 1 2 3 5 8 13 21 અને 34. એટલે કે લૂપ કેટલી વખત રિપીટ થઈ? 8 ટાઈમ્સ થઈ ગઈ, એઝ પર ધ લોજિક ઇઝ previously decided by all of us. So in this way this Fibonacci series works. Now let's see the same program in Notepad for better visibility. This is the code. Here the value of n1 is 0, n2 is equals to 1 fix. It prints 0 and 1 onto the screen. એટલે કે અહીંયા સુધીનો પ્રોગ્રામ એક્ઝિક્યુટ થયો હશે ત્યારે સ્ક્રીન ઉપર આઉટપુટ શું હશે? ખાલી 0 અને 1. હવે આ લૂપ 3 to 10 ટાઈમ્સ, 3 ને પેલો રિપીટેશન ગણો, 3 4 5 6 7 8 9 અને 10, ટોટલ 8 રિપીટેશન થયા. 8 વખત આ લૂપ ફરશે. અહીંયા અહીંની વેલ્યુ 3 લખેલી છે એનો કોઈ મતલબ નથી. અહીંયા આ રિપીટેશન 8 વખત પ્રિન્ટ થશે. શું કામ? કેમ કે સિરીઝ તમે જો આપણી ફિબોનાકીની જોશો તો એમાં 0 અને 1 પછીની 8 વેલ્યુ જે છે એ પ્રિન્ટ થાય છે. તો એ રિપીટેશન માટે આપણે અહીંયા ફોર લૂપમાં 3થી સ્ટાર્ટ કર્યું છે. અહીંયા કન્ફ્યુઝ થતા નહીં અને નહીં. હવે અહીંયા આપણે લખેલું છે n3 ઇક્વલ્સ ટુ n1 પ્લસ n2, 0 પ્લસ 1 ઓબ્વિયસલી કેટલા મળશે? આપણને 1 મળશે. એટલે અહીંયા n3 કયા પ્રિન્ટ થશે? 1. હવે n1ની માનો કે આપણે અહીંયા લખેલું જ છે આ n1 છે જૂનું, અને આ જે છે એ કેટલા છે? n2 છે. અને આ જે 1 આવ્યા હતા એ આપણા કેટલા આવ્યા હતા? n3. હું અહીંયા લખું એટલે આપણને વધારે આઈડિયા આવે. હવે અહીંયા શું થશે? n1 ઇક્વલ્સ ટુ n2 થશે. એટલે કે આ n1 જે 0 હતું એ કેટલા થઈ જશે? 1. અને આ n2 જે 1 હતું એ n3 થઈ જશે. એટલે કેટલા થશે? 1. એટલે n1ની વેલ્યુ 1 અને n2ની વેલ્યુ પણ 1 સેકન્ડ રિપીટેશન માટે થશે. હવે અહીંયા લૂપ છે રિપીટથી ઉપર જશે એટલે અહીંયા n3 છે. n3માં આપણે શું લખ્યું છે? n1 પ્લસ n2, એટલે આ 1 પ્લસ 1 થશે. એટલે અહીંયા આપણે નવો n3 કેટલો મળશે? 2. એટલે કે આ n3 હવે 1ની જગ્યાએ કયો થઈ જશે? 2. રાઈટ? આ આપણો રહેશે n2 અને આ આપણો રહેશે n1. હવે આ રિપીટેશન દરેક વખતે કન્ટિન્યુ રહેશે. ફરીથી જોઈએ આપણે. અહીંયા 2 પ્લસ 1 જે છે એ લખ્યા છે, એટલે 2 પ્લસ 1માં સોરી અહીંયા એક મિસ્ટેક છે. આ n1 થશે અને આ n2 થશે. હવે n1 પ્લસ n2 લખ્યા છે એટલે n3 આપણને નવો કયો મળશે? 2 પ્લસ 1 3 મળશે. રાઈટ? હવે આ n2 છે એ n1 થઈ જશે, n1 છે એ n2 થઈ જશે. એટલે નવો n3 કયો મળશે? 3 પ્લસ 2 5. આ આપણને મળશે n3. વળી રિપીટ થશે એટલે આ n2 છે એ n1 થઈ જશે. અહીં લખ્યું છે ને આપણે n1 ઇક્વલ્સ ટુ n2. આ n2 થઈ જશે. તો નવો n3 5 પ્લસ 3 કેટલો મળશે? 8. આ રીતે દરેક રિપીટેશન્સ જે છે એ કમ્પ્લીટ થશે અને છેલ્લે આપણી જે ડિઝાયર્ડ ફિબોનાકી સિરીઝ છે એ ડિઝાયર્ડ ફિબોનાકી સિરીઝ આ રીતની આપણને સ્ક્રીન ઉપર ડિસ્પ્લે થશે. લેટ મી રાઇટ ઓવર હિયર. આપણે જે પ્રેક્ટિસ કરી 1 બાય 1 એ અહીંયા સુધીની કરી. આપણે એકની નીચે ગોઠવીએ એટલે વધારે આઈડિયા આવે. રાઈટ? હવે માનો કે 8 પ્લસ 5 કરશો તો આપણને કેટલા મળશે? 13. 13 પ્લસ 8 કરશો તો 21 અને 21 પ્લસ 13 કરશો તો 34. એટલે અહીંયાથી આટલા ટોટલ તમે નંબર કાઉન્ટ કરો તો આ પહેલો નંબર, બીજો, ત્રીજો, ચોથો, પાંચમો, છઠ્ઠો, સાતમો અને આઠમો, અને અહીંયા 3 થી 10ની વચ્ચે પણ રિપીટેશન કેટલા છે? 8. This is the logic of entire program. I hope all of you understands that how for loop works. I know that day by day a logical part of the program becomes complicated. You need to focus on each and every word that I am speaking. You have to digest all these words. You have to focus on the program that I am writing. Then and then you can crack the logic of any program. But don't worry, if you practice by yourself at your home, either in mobile or a computer if you have, then it's very easy and helpful for the other programs also. Thank you very much students for listening me, and have a nice day. We'll continue our discussion of for loop with the practical concepts in next lecture. Right now, I'm terminating my lecture. Thank you very much.